How Kafka handles backpressure. Backpressure in Kafka arises when consumers cannot process data as quickly as producers are sending it, potentially leading to memory overflow, storage issues, or delays. Kafka addresses backpressure through mechanisms at the producer, broker, and consumer levels to ensure system stability and scalability. Producer-level backpressure management. Producers use buffering, batching, and retries to manage backpressure. 1. Buffering. Producers maintain a buffer.memory, to temporarily hold messages before sending them to brokers. If the buffer is full, producers block or throw an exception, max.block.ms, slowing their data rate. 2. Batching. Messages are sent in batches, batch.size, to optimize throughput. If brokers cannot accept more data, batching indirectly slows down the producer. 3. Retries. When brokers reject messages due to overload, producers retry sending based on retries and retry.backoff.ms, allowing the broker time to recover. Broker-level backpressure management. Kafka brokers regulate incoming and outgoing traffic to maintain stability. 1. Request queues. Brokers maintain queues for incoming producer data and outgoing consumer requests. Full queues delay or reject producer requests, signaling them to throttle. 2. Storage management. Retention policies, log.retention.ms or log.retention.bytes, manage disk usage, ensuring old data is deleted to make room for new data. 3. Throttling. Brokers enforce producer and consumer quotas, producer/consumer.quota.bytes per second, to limit data rates, preventing overload. Consumer-level backpressure management. Consumers pull data at their own pace, preventing them from being overwhelmed. 1. Pull-based model. Consumers fetch messages only when ready, avoiding the pressure of brokers pushing data continuously. 2. Fetch limits. Configurations like max.pulled-record and fetch.min-bytes control the number of messages fetched per request, aligning the data rate with processing capacity. 3. Processing time. Max.pull.interval.ms ensures consumers process messages within a specific interval. If exceeded, the consumer is removed, and partitions are reassigned to prevent data buildup. End-to-end coordination. Kafka's design ensures that backpressure cascades naturally. Slow consumers reduce broker storage availability, indirectly throttling producers. Brokers manage disk usage and enforce quotas to balance throughput. Producers adapt to broker capacity through buffering and retries.